Okay, so last night for homework, you had your video over the other portion of completing the square, specifically when we have a lead coefficient that's not 1. So that's what we're going to look at today. We've got some more practice problems on page 49 that we're going to take a look at. And again, we're looking at completing the square when our lead coefficient is not 1. Grab a pen here. So on page 49, we've got problems 3, 4, and 6 left to take a look at. So that's where we're going to start for today. Okay. So for problem number 3, notice I have a lead coefficient here of 3. The first thing I've got to do here is factor that out like a GCF. Even if it's not actually a greatest common factor for the entire problem, I'm going to factor it out as if it is. So I'm going to factor out a 3 from each term here. That leaves me with x squared minus 8x plus 9. So in this case, it was a GCF. Even if it weren't, I would still factor it out. And now with my stuff in parentheses here, with this trinomial, I'm going to complete the square just like we did yesterday. Okay, so I'm going to ignore the 3 out here for the next part of this, and I'm going to split the middle. So -8 cut in half would be -4 and -4. I'm going to add in a new c. I'm going to take my current c and just scoot it back out of the way. And then whatever I add here, I'm also going to subtract at the end. So this is all technically inside of parentheses with that 3 out front. I'm ignoring the 3 for right now. Remember, we fill in the blank with our cut in half number squared. So that would be 16. So I'm going to fill 16 into both of those blanks. And then my first 4 terms, if you want to factor by grouping, that's fine. If you want to use that shortcut that we talked about yesterday, that's fine too. I'll factor by grouping on this first one. So the GCF for my first group would be x. That leaves me with x minus 4. For my second group, my GCF would be -4. That leaves me again with x minus 4. My stuff in parentheses is the same. When I pull that out as my GCF, now I'm left with another x minus 4. And then we're going to combine our like terms at the end here. So 9 minus 16 would be -7. And then remember, this is all inside of big parentheses with that GCF of 3 on the outside. And then I'm going to write this as x minus 4 squared. So again, still inside of those big parentheses, x minus 4 squared minus 7, then with the 3 on the outside. This sort of big set of parentheses with the 3 on the outside here is not quite vertex form. I'm almost there, but I'm not quite there. So what I'm going to do for my last step is take this 3 and distribute it to both of these terms. When I distribute it to the x minus 4 squared, it's just going to land right in front there. And then I'll multiply it by the 7 here at the end. So this would become 3 times x minus 4 squared minus 21. And there's my vertex form. Now my vertex from here, I find exactly the same way that we found before. So my vertex for this function would be 4, comma, -21. Okay, that lead coefficient does not impact what my vertex is. I pull my vertex out of vertex form exactly the same way that we did yesterday. Questions for me on number 3? Okay, let's take a look at number 4. For number 4, my lead coefficient is 2. So I'm going to factor that out like it's a GCF. I know for this problem, it's not actually a common factor for every term. That's okay. I can't complete the square if I have anything other than 1 as my A value. So I have to pull that 2 out. Okay, I don't have a choice if I want to get this to vertex form. So I'm going to factor out that 2. That leaves me with x squared minus -3, or 3, I should say, divided by 2 would be 1.5. So I'm going to write 1.5x plus 8. Once I've got that lead coefficient pulled out, now I treat this exactly the same way. And again, when I cut my middle term in half, things are going to get a little weird. That's okay. So this would be x squared Negative 1.5 cut in half, this would be negative 0.75. So minus 0.75x minus 0.75x plus something plus 8 minus that same something. Remember, we fill in the blank with our cut in half number squared. I'm anticipating most of us would need a calculator to do 0.75 squared. That's okay. I'm going to pull mine out here to do the same thing that I bet you guys would do. So 0.75 squared would give me another weird decimal. That's okay. 0.5625. That's okay. When we're completing the square and the lead coefficient's not 1, sometimes we get goofy numbers. That's okay. And now these first 4 terms will become my something squared. In this case, because I've got these decimals that I'm working with, I'm not going to go through factoring by grouping. I'm going to use that shortcut that we talked about yesterday. We talked about it with number 5 because we had weird decimals there too. Remember what we noticed from each of these is that in parentheses, I end up with that cut in half number, okay? So in parentheses here with x, I'm going to get that cut in half number, so minus 0.75. So I'll end up with that as my factored form of these 4 terms. And then I'm going to combine these like terms. So I need to do 8 minus 0.5625. 8 minus 0.5625. That gives me 7.4375. And now remember, this is all in parentheses with that 2 outside. So my last step is to distribute that 2 back in so I have my vertex form. So this would be 2 times x minus 0.75 squared. And then I need to do 2 times this number. And I got 14.875. Questions for me on number 4? Again, I used some of those shortcuts that we talked about yesterday because we had some goofier numbers there. That'd be a little trickier to be able to use my factor by grouping there. So that's why I elected to use that shortcut instead. And then finally, let's take a look at number 6. Number 6, my lead coefficient is -1. So I'm going to factor -1 out of every term. So this would be x squared minus 6x plus 2. So I've just changed the signs on everything. And now again, I'm going to split the middle term. So x squared, -6, cut in half would be -3. So -3x minus 3x plus something plus 2, and then minus whatever it is that I fill in the blank here. Remember, we fill in the blank with our cut in half number squared. That would be -3 squared, which gives me 9. So I'm filling in both blanks with 9. Anybody have a strong preference to use grouping to factor this? Strong preference to use our shortcut? Okay, I got like 1 total hand. So we'll go with that. So remember, these guys are going to factor into that x with something squared. Whether you go through factoring by grouping or you use the shortcut, you're going to end up with the same thing. So we're going to get x with the cut in half number, so -3 squared. And then combine our like terms at the end. 2 minus 9 would be -7. And then don't forget that we're in parentheses with that -1 in front. So we're going to distribute in this -1. And our vertex form for our function would be -x minus 3 squared. And then -1 times -7 would be +7. So there's my vertex form. And my vertex from here would be +3, +7. Really quickly on the practice work that you guys started yesterday, It also asks you about whether the vertex is a minimum or a maximum. So remember, to determine if the vertex is going to be a minimum or a maximum, I kind of need to know what the end behavior is going to be, which we can get from the degree and the lead coefficient. Our degree is 2 on all of these because they're all quadratic functions. Yes? I don't understand why you put the -1. This guy here? So the -1 here is because our lead coefficient was -1. So anytime you see anything in front of x squared and you want to change it to vertex form, you have to start by factoring that out, even if it's just negative. Okay, so we did it here when it was 3 and here when it was 2. Here, I know it doesn't look like anything special because it's just the negative, but I still have to factor that out the same way I did when I pulled out the 2 and when I pulled out the 3. Does that make sense? I have to change the sign of all things. Yeah, when you pull out the negative, all the signs change here. Okay, so minimum versus maximum for your vertex. Your degree for all of these is going to be 2 because they're all quadratic functions, right? And that's the deal with a quadratic function. It's an x squared function. So your ends are either both going to go up or both going to go down. To decide which version you have, you're looking at that lead coefficient. Is it positive or negative? If the lead coefficient is positive, you've got this picture and your vertex is going to be a minimum. If your lead coefficient is negative, like number 6, you've got this picture and your vertex would be a maximum. Does that make sense for anybody who maybe had a rough time with that yesterday? Okay, so here's what we're going to do next. I want you to work on the back side of the paper you got yesterday. So these are all going to be problems where you have a lead coefficient you need to factor out to start. Okay, you're working on those backside problems. And then the last few minutes of class, we're going to do a quick check over completing the square. Okay, this process that we worked on yesterday and today. So please ask questions as you're working. If you get stuck, if you need help, if you just want to check your answer, please make sure you ask questions. Okay, so on the back side of that paper, we're working on completing the square and changing to vertex form. Again, all these problems are going to have something as a lead coefficient that you need to factor out. So the first one is the negative, then we've got a 2, and I think the bottom of the page has some 3s, but all of them have something you need to factor out.